Okay, so today we're going to be doing problem 2 of lab 6. So first we need to consider the data set. S equals linspace -1, 1, 10. Y equals exp -10 times x squared plus a dot. So what degree is needed to do the polynomial interpretation? We can figure this out because x equals linspace -1, 1, and that's going to be 10. So that 10 needs to be -1, and that's going to give us a degree of 9, and that's going to be our degree. Plot the interpolation polynomial, comment on how it looks. Okay, great. So the first thing we need to do is we need to do p equals polyfit x, y, and 9. So that 9 is going to be our degree, and polyfit, what it does is it returns coefficients for a polynomial, px, or p in this case, or degree, which of degree 9, that is best fit for the data in y. So what all it is it's really doing, it's going to give us the best fit for this data. So now we need to plot, and the first thing we're going to do is we're actually going to scatter. So we're going to scatter x and y, which is right here, and put that as filled, and we get these blue dots over here. But we're not done. We're going to hold on, and we want to create an xq value, which is going to be the range of -1 to 1, and a yq value, which is polyval p and then qx. So that is this p right here. And we want this to be that polyfit, which is going to be that nice best line fit. And then we want that xq, which is right here. We want that range to be -1 to 1. And what polyval does, it evaluates p at each point of xq. So what it's really doing is it's evaluating from each data point. So it's going, oh, yep, this is what it is. And then you can see a slope is different from each data point, and that's what it's doing. And so then we're going to plot it, xq and yq, and we want the grid, and we want to hold off. So I can see this is very smooth. It's a little funky just because this line isn't going straight across, which is kind of odd. Like this line isn't going straight across. But other than that, these lines look really good. This has a curve in it. This is going straight. But we could fix this if we wanted to, because this isn't 100% accurate. So now we're going to plot a spline that interpolates the data using a knot, and conditions, comment on how it looks, and compare to the polynomial of question 1. Okay, so we're going to use the same xq as before, and then we're going to use a different yq, because remember yq, we used that polyval. We don't really want to use that anymore because it made this funky little curve right here. So we're trying to get rid of that. So we're going to do spline. And spline returns a vector of interpolated values corresponding with the q point. So to do this, we're going to do yq equals spline xy xq. Hold on, and we're going to want to plot that. We're going to want to plot that xy and that xq, and we want to do that black dotted line. So as you can see, that spline really helped connect this instead of that polyval. It's going to go straight across here, which is what we wanted to see instead of these weird downward slopes. It would go straight across. So that looks a lot better. And then how can we further improve this and make this spline by using clamped? So clamped is just another function that you can use with spline. So we're going to use that xq as the same, but we want to change that yq again. And so we think that we can make this yq even better than it was before. Because if you zoom in on it, you can see right here that this x dotted line just goes a little bit of that. It's not exactly really straight across. So in order to do that, we can still do that yq equals spline, and we're going to do x, and then this is like the spline formula. It's going to be your first slope, and then y, and then your last slope. So first, we want this to be 0. So we want first slope 0, last slope 0. And there's y. And then we want xq. Okay, fine. Hold on. We want to plot that and use a blue dotted line. We're going to hold off. And to really see how it's doing, we're going to do that limit from -1 to -0.7. And that's what you get right here, is blue dotted line. It's going straight across, and that is perfect. So that x dotted line, that black dotted line, it's a little above, doesn't look great, so we can use this clamp method to go straight across, and that looks really good. So that's the questions we have. Thanks.